Hi, in this video, I'm going to deal with special cases of inequalities dealing with unions. So remember that union deals with the word or, and so it means at least one solution satisfies the inequality, or at least one solution set is present, so or true at one time. Okay, so remember that both don't have to be true, just like in the intersection, but in the union, at least only one has to be true. Okay, so let's deal with this one. So we have x is greater than 5, right? So x is greater than 5, or x is less than 5. So either or can be true. It doesn't have to be both. Okay, so 5, 6, 7, and then over here maybe 4, 3. Okay, so I'm going to graph 5. So at 5, it's open, correct? And so, and I wanted to do that in a different color. So at 5, I have an open circle, and it looks like greater than, so those values are to the right, and they continue on forever. And x is less than 5, I'm going to do that one in a different color. Okay, so again, 5 is not included, and so these values are less than, and so they point to the left. Well, it looks like my inequality is true after 5, and it's true before 5. But what happens at 5? Well, it looks like the inequality is not true. So because neither 5 is not included in either inequality, then 5 is not in my solution. So you can leave it as this, as x is greater than 5, or x is less than 5, or you could say all real numbers except 5. Okay? You could say that, or you could say excluding 5, or all real numbers except other that are not x equals, or x is not equal, but x is not equal to 5. Okay? So this is a special case. You probably won't see this one often, but sometimes you will run across that. And it's okay to leave it like this. X is less than 5, or x is greater than 5, or vice versa. Or you could just say all real numbers except 5. So that basically means that 5 is the only number in all of the numbers that are possible that is not included. So in all the numbers that exist from negative infinity to infinity, basically 5 is not included in that solution set. Okay? Now let's look at another example. So we have all real numbers. So we have example 2. This is example 2. The first one was example 1. Forgot to number those. Okay, so we have x is greater than or equal to 2. So I'm going to start at 2. Before 2 is 1, 0, -1, and after 2 is 3, 4, and 5. Okay, so I'm going to graph x is greater than or equal to 2 first. So that's an enclosed circle. Graph is going to the right for values that are greater than or larger than 2. And for the second inequality, x is less than 2, it's an open circle, and the values are going to the left for all the values that are below 2. Okay, so in this case, it's slightly different from the graph above, because while my inequality is true in one region and true in this region, true, that's supposed to be a t, but false at the number 5, this one is a bit different. Okay, so it's true in all the values that are less than 2, so that one is true. And it's true in all the values that are greater than or equal to 2, so it's true here. But then remember, if it's greater than or equal to 2, then that's 2 is included in the solution, so it's also true here. So it looks like regardless of where you are on the graph, it's true everywhere, okay? So that means that the solution set, you could leave it as this, but it's important to understand that what this means is that it's all real numbers. Okay, or from negative infinity to infinity. Okay, so all real values of x, or whatever you name your variable. Okay, so I hope this has helped you in interpreting your different types of solutions, and I will see you in the next video.